In this video, we focus on IUPAC nomenclature of amines, with a specific focus on acyclic amines, such as the molecule we see here, where the amine is not part of a ring system. We'll break the nomenclature of amines up into the three different types of amines: primary amines, secondary amines, and tertiary amines, beginning here with primary amines. Remember that primary amines are amines such as this one here, where the nitrogen atom is connected to only one carbon atom directly. In other words, primary amines are ones that have an NH2 group. In order to name primary amines, we will follow the rules shown here, which are going to be very analogous to how we named alcohols, except in the case of alcohols, we use the OL suffix to denote that the molecule was an alcohol, whereas here we'll use the suffix amine to denote that the molecule has an amine functional group. Let's begin by finding the longest carbon chain that contains the carbon that is bonded to the nitrogen in order to assign the parent name. And the parent name is going to adopt the template of alkanamine, such as ethanamine or propanamine, etc. So, taking a look at the structure over here and finding that longest carbon chain that contains the carbon that is bonded to the nitrogen, where the carbon bonded to the nitrogen we recognize as this carbon atom right here that I'm highlighting in pink. Finding the longest carbon chain that includes that carbon, we see will take us through the molecule like so. When we get to this point, we have a branch where we could come up to here or over to here. Take whichever pathway is longer to find the longest carbon chain. If there's a tie, which is the case here and here, then we can go either way, meaning that there is going to be symmetry there because both of these are one carbon chains. Now we found the longest carbon chain that contains the carbon that is directly bonded to the nitrogen, and we will name that as our parent name of alkanamine, starting numbering that beginning at the end closer to that carbon that's bonded to the nitrogen. So let's go ahead and number that starting from this end, because this is the end closer to that carbon number 2 where the nitrogen is bonded. So given that we have 5 carbons in total in our chain and the molecule is indeed an amine, following that template of alkanamine, that indicates that the parent name of this molecule is going to be pentanamine. So I'm going to go ahead and write out pentanamine. And keeping in mind that we would give different constitutional isomers by placing the NH2 group at different carbons of the chain, for example, it could be at carbon 3 instead of carbon 2, we need to specify where that group is located. And since it branches off of the chain at carbon number 2, I'm going to refer to this molecule as 2-pentanamine. Synonymous to that, I could have alternatively said pentan-2-amine. And the version that I've written here at the bottom is actually more in agreement with the most up-to-date IUPAC rules, but you will see both of these ways of representing amines commonly seen in the literature, and so it's a good idea to be aware of both of these and able to apply both of them. Both would be considered generally to be accurate. So at this point, we've taken care of step 1. We found the longest carbon chain. We use that to determine the parent name, keeping in mind that that longest carbon chain has to include the carbon here that's directly bonded to the nitrogen. We numbered that chain beginning at the end closer to the branch, meaning closer to the amine branch. We indicated the numerical location of that carbon that has the amine branch coming off of it in our parent name by calling it 2-pentanamine or pentan-2-amine. And then finally, we need to name and number the other branches as prefixes that come before the parent name, as we have done before when naming alcohols or other molecules. In the case of this molecule, I see just one branch other than the amine, which we already accounted for in our parent name, and that other branch that I see is at position number 4 of the chain. We have a 1 carbon branch coming off, a methyl branch in other words, and we need to specify that in the name. At position 4, 4-methyl dash 2-pentanamine, or down here 4-methyl pentan-2-amine. Remembering that we separate numbers, such as the number 4, from letters, such as the M for methyl, using dashes. And if there is no number separating the two, such as when we run methyl and pentan together down here on the bottom, we put no space and no dash. So this is going to give us the name for this primary amine. Now, what about the case of a secondary amine? Remember that a secondary amine is an amine such as the one that we see up here, where in this case, our nitrogen is directly bonded to two carbon atoms here and here, making that a secondary amine. We'll follow these rules, which are going to look quite analogous to naming primary amines, except for the fact that we have to account for the extra carbon chain that is bonded to the nitrogen, because it's no longer the case there's just one carbon chain bonded to the nitrogen. Instead, we brought in a second chain. So how do we go about dealing with that? Well, starters, let's find the longest carbon chain that contains the carbon that's bonded to the nitrogen, and we'll assign the parent name based on that. So here we have two options. We have a carbon chain here that's directly bonded to the nitrogen. That's 3 carbons long. 1, 2, 3. Down here we have a carbon that's directly bonded to the nitrogen. That's part of a 5 carbon chain running through here. Choose the longer of the two chains to form the parent name. Therefore, since 5 carbons is certainly more than 3, we choose the chain down here as our parent chain, and that's also going to include our nitrogen atom in the parent name of this molecule. So I'm going to highlight the nitrogen atom there as well to indicate that we're taking care of that here with step 1. And we'll name this as an alkanamine. Since it has 5 carbons in total, it's going to be pentanamine. We'll number the chain, beginning at the end closer to the carbon that's bonded to the nitrogen. This matches completely with what we were doing for primary amines. So we start numbering from this end, because that's the end closer to where the nitrogen branch comes off. 1, 2, 3, 4, 5. That's 5 carbons in that parent chain. And so we refer to this as pentanamine, as indicated in step 3. We need to indicate the numerical location. That's a carbon number 2. So we call it 2-pentanamine. Or alternatively, as we saw with our primary amine, we could also refer this as pentan to amine, and that would be suitable as well. Now from here, what we have accounted for in our name so far is everything highlighted in pink. We've accounted for the 5 carbon chain and the fact that there's an amine group coming off at carbon number 2. What we haven't accounted for is the carbon chain coming off of the nitrogen that comes off up here, that 3 carbon chain. So how do we go about dealing with that? Well, the shorter alkyl group, such as this 3 carbon chain here being shorter than the 5 carbon chain that we used below, is going to be named as an N-alkyl group. So in the specific case of this example, we have a 3 carbon chain, so we would call that an N-propyl group. If it was a 1 carbon chain, we'd call it an N-methyl group. 2 carbon chain, N-ethyl. If it was an isopropyl group, we'd call it an N-isopropyl group. You get the idea. And we plug this in at the front of the name just like we would any other branch name. The reason why we use the N there rather than a number is because the N will specify for us that the 3 carbon chain is bonded directly to the nitrogen. So anytime you see an N as a prefix, that N is going to tell us that whatever group comes immediately after it is directly bonded to the nitrogen atom. And so this will confirm the entire name of the molecule because we've accounted for all of the atoms of this longest carbon chain falling under pentanamine at position 2 is where the nitrogen branch comes off of the amine group. And then N-propyl designates that we have a 3 carbon chain also coming off of the nitrogen atom. Now, what about tertiary amines? We're going to see that the pattern repeats here for naming tertiary amines as it did with naming secondary amines. We start by finding the longest carbon chain that's connected to the nitrogen atom. The nitrogen atom being here, we have 3 carbons in this chain, 2 carbons in this chain, and 5 carbons in this chain. The 5 carbon chain wins and becomes the parent name. So I'm going to go ahead and highlight that in pink here as our parent name. And I'm going to include the nitrogen in that highlighting as well because this parent name incorporates the nitrogen atom into that name. And since it's 5 carbons, it's going to be pentanamine. We number from the end closer to where the nitrogen is bonded to the carbon of the chain. So of our 5 carbon chain, I'm going to call this 2-pentanamine. As we saw before, we can equivalently refer to this as pentan 2-amine, as I run a little low on space there at the edge of my page. And then from there, we've taken care of steps 1, finding the longest carbon chain that has a carbon directly bonded to the nitrogen, number the chain beginning then closer to that amine group branching off, indicate the numerical location of the amine branching off, and then here, this is where we deviate a bit from naming secondary amines, or I should say we extend a little bit, we're not really deviating. And what we're doing here is number, or rather name, the shorter alkyl chains that are bonded to the nitrogen as N-alkyl prefixes and list those in alphabetical order. So since it's a tertiary amine, we have two N-alkyl groups. That's the alkyl groups that we haven't named as part of the parent chain in pink. So we have here in yellow this 3-carbon chain, which we would refer to as an N-propyl group. And we also have over here a 2-carbon chain, which would become an N-ethyl group. Now list these in alphabetical order as prefixes. So therefore, our name here would be N-ethyl, because E comes before P in the alphabet, dash N-propyl, dash 2-pentanamine, or down here, N-ethyl, N-propyl, and pentan-2-amine coming right after that. These two names would be equivalent. And you'll notice here that I did put a dash between N and the alkyl group names because we treat N like it is a number. The reason why we don't use a number there is because we need to be able to designate that the alkyl branch is directly bonded to the nitrogen and not bonded somewhere else in the parent chain, and that allows us to make that distinction. Now, to finish up, in some cases, you will come across symmetrical amines where you have multiple groups that are identical, such as the case here where we have 2 isopropyl groups directly bonded to the same nitrogen atom. The nomenclature of these takes a slightly different course than the nomenclature that we looked at for regular old primary, secondary, and tertiary amines that have asymmetrical groups, and that when you have symmetrical groups, you can refer to it as di, name the group here, in this case isopropyl, and then add the word amine to it. So di-isopropyl amine indicates to us that we have a nitrogen atom directly bonded to 2 isopropyl groups. Over here at the right-hand side, we have a structure that has 3 propyl groups, and so we could refer to this as tripropyl amine. And this will be a shortcut for naming symmetrical amines that is perfectly acceptable, is to name the alkyl groups using di or tri to indicate how many of them there are, and then tag the word amine on.